So this lesson today, this is going to be lesson 7, building linear models from data. This is from chapter 4, section 2. So this lesson, we're going to be working with data. And again, we're going to be using the TI-84 to draw what we call scatter plots. And we're going to determine what's called the line of best fit. So that's kind of see here as we're doing the line of best fit here. So vocabulary is a linear relation. Remember, a relation is a set of ordered pairs. A linear relation is going to be a collection of data points that resembles a line. So remember, ordered pairs you plot. These plots will make what we call data points. So somebody's already collected this data. If the data resembles a line, we call it a linear relation. So if you look at these 4 graphs, some of those represent lines and some of them do not. So this first one, notice how it kind of goes straight. This would be considered linear. B, notice how it kind of curves. This is nonlinear. And C, remember that's kind of snake-like. That's more of a cubic function. That's also nonlinear. And this has kind of a curve to it, so that's not necessarily linear. It's not bad, but linear, we're really looking for something that makes it more of a line. So A really is the best description of what we call linear data. So what's going to happen is we're going to draw and interpret a scatter plot, and we're going to be using the TI-84 to do this. So we're given this data. We really don't know what it pertains to at this time. We're just kind of at the beginning level of just trying to use the calculator without having to think more than that. So to do a scatter plot using the calculator, let me see if I can make this happen for us. See if I can get this off to the side there. So on our calculator, since we're going to be working with graphs and stuff, if you hit the Y equals button, notice that I've got data, I've already got a line in there, so we probably need to clear that off. Another thing is, if you hit the zoom button in number 6, if you hit that one there, that will set our window back to its normal settings. So -10, 10, 1, -10, 10, 1. It kind of gives us that stuff going on there. So we got that going on. The table set, like I said, you usually want that to be 0 and 1 if we use the table. So all that looks back to normal. Now to do a scatter plot, one of the things we have to do first is we have to do what's called turn the diagnostics on. So to do that, we have this catalog button down here next to the on button. To get to that catalog button, since it's above the 0 and it's in blue, we have to hit the second button first, and then we hit the 0 to activate the catalog button. So it does what's above it, the catalog. And what we want to do is go down to where it says diagnostic on. Right now, if we scroll, it's just going to go by A, B, C's and stuff. So to try to take a shortcut, I'm going to hit the alpha button, and D is located above the X to the -1 key. So if I hit the X to the -1 key, it's going to do that D. And you got to do that twice. Hit the alpha button again and hit that X to the -1 key, and it'll move me on down to the D's. So if I scroll on down now through the D's, what I want to do is I want to turn the diagnostics on. So if I hit enter, it says diagnostic on, but I have to enter again for it to say done. So we have to enter twice there to make that happen. So the diagnostics is on, and now this thing will do the scatter plot the way we want it to do. Now to do a scatter plot, that's what's called a stat plot. Notice how it's above the Y equals. To do a stat plot, we have to hit the second button, hit the Y equals button, and it turns us to this screen. So what we want to do is we want to choose number 1. We're going to do a plot, and we're going to turn it from off to on. So let me go back up there and hit enter and turn that on. That is now on. We want the graph to be like a bunch of little dots, just like we were doing. This is called a scatter plot. So we don't want to change that one. The list, we're going to keep that in L1. So the X list will be in L1 and the Y list will be in L2. And it looks like the color here is going to be blue on my screen. You may not have that option on yours. You may not have colors. So that all looks good. So let me hit the button and hit the mode button to quit. So let me take you through that one more time. So to do the diagnostic on, what I did was hit the alpha. I'm sorry, I have to go to the catalog first. So I hit the second button, hit the 0 for the catalog. I now didn't need to get to the diagnostics, so I had to hit the alpha button, hit the X to the -1 key, have to hit the alpha button and the X to the -1 key again to get down to the Ds. I have to now move on down to where it says diagnostics on, hit enter there, but you got to hit enter again to say done. To turn the stat plot on, you have to hit the second button again, and the stat plot's above the Y equals button. So you have to actually hit the Y equals button, and it does what's above it, the stat plot. Notice mine is on now. If I needed to turn that off, I would hit enter and go back in and turn that off. Right now, we want to just keep everything on. So we're kind of good to go. So I hit the second button and hit the mode button to get out of there. This screen here, I'm gonna go ahead and clear it off and make it just look a little bit more plain. Now to get to putting the data in, this is where the statistics button comes in. So if you're gonna do probability and statistics, this is where you'll start playing with some of these buttons here. So there's a stat button, STAT. If we hit that button, and where it says edit, we want to edit, so we're going to choose that one. So list 1, if you need to clear your list, you just got to move up and hit clear, and it'll clear the data off, and then you move back down. So if I had some data here like 9, hit enter. If I have a 6 and hit enter. If I want to clear that data off, I just move up to where it says L1, I hit clear, and if I move back down, that data disappears. So L1 is going to be the list of the X values here. So I have a 3. If I hit the down arrow, I think it may take us to the next one. So all you have to do is hit the directional pad as well. 3, down arrow, 4, down arrow, 5, down arrow, 6, down arrow, 7, down arrow, 8, down arrow. That looks good. Now let's slide over to list 2, and I'm going to list the Y list. So this is going to create the order pairs in this area. So we have a 4, down arrow, 6, down arrow, 7, down arrow, 10, down arrow, 12, down arrow, 14, down arrow, 16, down arrow. So I've got my data entered, but notice how I don't have the same amount of numbers. So I probably did something wrong there. 4, 6, 7, 10, 12, 14, 16, 3, 4, 5, 6, 7, 8. I needed a 9, didn't I? So let's come back over here. I need a 9 in there as well, down arrow. Now I've got a balanced out thing. That looks pretty good. So again, I hit the second button, hit the mode button to quit. So that math is now entered into the calculator. So once the data is plotted, we can see here. Let's see what else we have here. So once the data is plotted, a line can be constructed using 2 data points. So let's actually look at the graph. So if I hit the graph button up here, notice that I really don't see much of the graph. Based on my order pairs, you know, my X's are going out to about 9 and my Y's are going out to about 16. So I probably want to change my X's and Y's. A good number to use is maybe like 20. So my window, I don't need much of a since my X values are all positive, we can change our X min to probably 0 if we want. Our X max, if we want to, we can change that to 20. And a scale, maybe make it go to 2s. And that'll give us more than enough view looking at that data since it only goes 3 through 9. On the X min, again, since everything's positive, we can just choose 0 for our Y min. Our Y max, we can go 20 again. That should cover it. And again, if we just go by 2s, that kind of gives us some stuff going on here. So now if I hit the graph button, Notice that gives me a better picture of my graph. I have now 1, 2, 3, 4, 5, 6, 7 data points. 1, 2, 3, 4, 5, 6, 7 data points. So I have the graph sketched there. So that would be what we call a scatter plot. Now, does it look like it would be does this data look like it would be linear, if you will? This graph looks very linear, doesn't it? So this data would represent a linear function. So what we want to do is to graph the linear function, we've done that. So what I want to do now is I want to write the equation for the linear function. So once the data is plotted, we're going to be using 2 data points to create an equation of a line. What we're going to do is we're going to use the first pair and the last pair of data points, and we're going to write an equation of a line. So write an equation of a line, remember we're using the form y equals mx plus b. So to find the slope, remember we have to use the slope formula, m equals y2 minus y1 over x2 minus x1. In other words, the change in the y's. So I'm going to go 16 minus 4, the change in the y's, and I'm going to go 9 minus 3, the change in the x's. So 16 minus 4 will be 12. 9 minus 3 will be 6. So that reduces on down to a 2. Now, to find b, we use the equation y equals, now I'm going to replace the m with the 2. So I have now equal y equals 2x plus b. But to find b, what I'm going to do is substitute one of these data points in for x and y. I'm going to, again, just use this first pair. This 3 is going to go in for x. This 4 is going to go in for y. And I'm going to find b by using those points for x and y. So the 4 is going to go in for my y. And I have 2 times 3 plus b. So it's going to be 4 equals 6 plus b. And you have to subtract 6 on both sides. So that's going to give me a -2 equals b. So my equation is going to be then y equals 2x minus 2. That would be the linear equation. And what I can do now is actually graph it. So to graph it, I hit the y equals button, and I can type in 2x minus 2, hit the graph button again, and notice how that draws me a line through the data, and you can kind of see that it's very, very linear as that line passes through almost every point. It even touches that 1 point. So it touches the 6 of the 7 points, and it barely misses the 7th point. So this is very good data for a line. The TI-84 can also be used to determine what's called the line of best fit. The equation of the line of best fit, it can be rounded to 4 decimal places. So to find the line of best fit, what we do is we use what's called the linear regression line. So the linear regression is what we're looking for. So to find the linear regression line, what we do is under stat, if we go over here to calculate, so if we slide over to calculate, number 4 has LINREG. Notice that stands for linear regression. What that stands for is the line is best fit. So this calculator, instead of me doing this by hand, like I just did, this calculator can actually create a line of best fit itself, where I wouldn't actually have to do this math. Let's see how close it is to ours that we did by hand. So if I hit enter, so it's asking, yeah, we're using L1 for the X's, we're using L2 there. We're not using a frequency list. We're not storing any data there. Let's go ahead and just calculate it. So everything there is correct. So in a linear regression, notice how it said AX, oops, it had AX plus B. And there, the A actually is going to stand for the slope, and the B is going to be the y-intercept. So when I write the line of best fit, they're using the equation like I'm using y equals mx plus b. They're actually using y equals ax plus b. So they're using an a instead of an m for slope. So what I have then is y equals, and then my a is going to be 2 point, and I have to round it to 4 decimal places. So it's going to be 0, 3, 5, there's the 7, and since there's a 1 after the 7, it would just stay a 7. So 2.0357 would be the coefficient of x. That's going to be the slope. And then your b is a negative, so I'm going to have a minus then 2.3571. And then that 4 would say keep it as 1. So that would be the line of best fit. So what I can do now, if I want to, is I actually can graph the line of best fit. So if at y equals, I can clear off my line, and let's see if there's z any better than ours that we had. So 2.0357. It should be better than ours because it's out to 4 decimal places. We didn't go out 4 decimal places. Minus 2.3571. If I graph that, notice how there's not much difference between our line and that line because those are still very, very much the same. So the line of best fit would be very similar to our line. And notice that the line of best fit has to pass through most data points. And that's what we're trying to do here with the line of best fit, is draw a line that best passes through all the data. In that case, it looks really good. Okay, so let's see what else we have over here. The next thing they have is what we call this correlation coefficient, which is R. R is going to be this value between -1 and 1. The closer R is to 1 or -1, the better the data is if fits the linear regression line. It can be a good predictor. Let me kind of maximize that a little bit. So R, again, is the value between -1 and 1. The closer it is to 1 or -1, the better the data fits a linear relationship. And a line can be a good predictor of the data. And that's what this is all about, is you're trying to make predictions, and that's what it's all about. So like with diseases and things, if you're trying to do like the stock market, you're just trying to predict. The better you can predict things, you have a better chance to prepare for stuff, especially like for the weather. So if R is closer to 0, then the data is probably not going to be a very good line. So the line won't be a good fit for the data, and it therefore won't be a good predictor. If R is less than 0, in other words, if R is negative, the slope will be negative. In other words, the graph should be decreasing. If R is greater than 0, the slope will be positive. In other words, the graph should be increasing. So what I want to do is determine the value of R using the TI-84. So the way that we do this is if we go back to the calculator, if I go back to stat, and if I go back to calculate, if I go back down to that linear regression again, and go through all this again, calculate, notice that R is given on that linear regression. And I think here, let's just round it to like 2 decimal places. So R would be like, I think we said 0.99, if I was right. Let me double check that. Yeah, actually 0.96. So 0.996. So if I round that, that's going to round all the way up to 1.0. So that would be like 1.00. So notice that this data really is sitting right on top of 1. So that means this line would be a very good predictor to this. So we'd have a very accurate piece of data there. So the correlation coefficient kind of tells you how good the data and the line fit. So if R is close to -1 or 1, that means we have a line that's going to be a really good predictor. So let's look at this next example and see what we can do with all this. So again, we want to make a scatter plot. So if I go to my calculator, if I go to y equals, let's clear that all off. My window settings, let's leave those like that for the time being. So I think we're okay there. So let's go to stat, and we want to click 1 for edit, and we want to clear these lists off. So I'll go up and clear, come down, come over, go up and clear, And now come back down, come back over. So let's see if we can enter some data based on this here. So our X list is going to be the L1 list. So we have a -30, come down, -27, come down, -25, come down, -20, come down, -14. And that looks like that's it. Come down, slide over. My Y list, 10, come down, 12, come down, 13, come down, 13 again, come down, and 18, come down. And it looks like I got my data all there. I think the stat plot is already on, so I should be able to just go to graph at this point. Let's see, I don't see my data. Because my X's were all these negatives. So no data there, is there? So I need to change my window where my X's are actually all negative. So go to window, max min, let's make it maybe -40. Max, since there's nothing, oops, I didn't get a -40 there. So -40. If I come down, max again, there's no positive number, so we can just say the X max is 0. If we will make the scale go by 4s, that may not be too bad. And this 20 still looks pretty good for our data. So I'm not going to change the Y part of it. So if we graph, we do have our data there. And I don't know what the scale is. Like if you're looking at the math in my lab, the graph will actually have the window settings in the choices. So you can set your window choices according to what they give you in there. Notice this data is not bad. It's not as good as the other data, but still it looks kind of linear. So this looks kind of linear. So what we want to do next is we want to graph, we actually want to find the equation of the line. So we're going to find this equation of the line. I'm going to bring this back over. So to find the equation of a line in part B, we're going to use again this equation y equals mx plus b. And we're going to use the first data point and the last data point in creating our equation. So again, the first thing to do is find the slope. So again, you have to find the change in the y. So it's going to be 18 take away a -14. And on the bottom, you're going to have 10 take away a -30. So that's going to be 18 plus 14 over 10 plus 30. And that's going to be what, 32 over 40. There is a greatest common factor of 8 there. So that's going to turn into a 4, and that's going to turn into a 5. So 4/5 is going to be my slope. So now I have this y equals this 4/5 x plus b. Now to find my y-intercept, I'm going to choose one of these data points. I'm going to just choose the first one here. So the 10 is going to go in for x. I'm sorry, the 10 is going to go in for y, and the -30 is going to go in for x. So I have 4/5 times this -30, then I have plus b. Notice that 5 does go into -30 6 times, or -6. So that does divide out there. So I have 10 equals, and then -6 times 4 would be -24 plus b. Add 24 to both sides. It looks like b is going to equal this 34, if I did my math correctly. So the equation of my line is going to be y equals this 4/5 x plus this 34. So let's see if we can graph that over here and see if that actually works for us. All right. So if we go to y equals 4/5, I'm going to put that in parentheses, 4 divided by 5 close parentheses, and then x. That'll keep the x on the outside, not on the bottom. If you don't do that, the X would appear on the bottom and confuses it. Plus that 34. You can also use the fraction button if you want. So if I hit graph, let's see if it actually, notice how it does go through my data points a little bit. So it looks like we did a fairly decent job of that since it passes through there. I don't think it's the best line because I think the line of best fit should actually go lower. But let's see what happens here as we move on. Okay, so we did our scatter plot. We found our equation of our line. That's going to be that y equals this 4/5 x plus this 34. We graphed the line on the scatter plot, and it didn't look bad. Our next step is to use the TI-84 to determine the line of best fit, round the numbers to 4 decimal places. So now we're going to use this linear regression line. So they're using this y equals this ax plus b form. So we have to identify the a and the b in this problem. So if we go back to our calculator, now to find the linear regression line, we have to hit the statistics button again. We have to slide over to calculate, and linear regression is that number 4 down there, ax plus b. If I hit enter, it says, are we using list 1? Yeah, we're using list 2 for y's. So nothing here changes. We just hit calculate and it does it. So now it gives us these decimals. So the a to 4 decimal places, let me kind of move this back over to the side so I can write. Get over there and then get this a little bit bigger. So I'm going to just, for the time being, I'm just going to put this down here. A is going to equal this 0.4421. And this B is going to be 23.4559. And there's a 1 there, so that stays. And also we have to do that correlation. So there's that R. And R, let's just go to 2 decimal places. So 0.94 would be the R. So we'll go ahead and mark that down as we go forward, so I don't have to go back and forth. So we need those 3 things from that screen. So if I come back over here, my line of best fit based on the calculator is going to be y equals 0.4421x plus 23.4559. So let's go ahead and graph that on the calculator and see what that looks like. So if y equals, if I clear mine off and put 0.4421x plus 23.4559. That don't look right. Let's clear that off. So y equals 0.4421x plus 23.4559. That looks better. If I hit graph, notice that actually goes through the data a lot more evenly than our other one. We didn't have a bad line, but this line looks like it fits the data even better. So it's going to be a better predictor of future information than ours that we just did by hand. So again, this data looks like it should fit the line really well. So our R value should be really, really high as well. So if we go back to the R value, notice our R value was really, really close to 1. So that means our line of best fit should be a good predictor since it's close to 1. So that 0.94. So again, we used the TI-84 to graph the line of best fit. We did that already. And we saw that looks really, really good. All righty. So hopefully you find that useful as we move on. You know, what else do we have here? Oh, we got an application. What in the world do we got to do here? Okay. So let's just draw a scatter plot, treating the width as the independent variable. Okay, so independent variables is the same thing as our X values, and the length is going to be our Y values. So to do a scatter plot on this, let's see if we can slide this off to the side here. So again, to put the data in, we have to go to stat. We hit 1 for edit. We have to clear off our existing data. Come down. So let's put this data in, see what we have here. 200, 350, 180, 300, 500. Let's see if I can get this data in here. 400. Another 500. And 800. 100. 50. This is where I don't like statistics stuff. It's a lot of putting in. But it's cool. Once you have it in, you get to really study the data. You just have to have patience getting it all in. I sometimes don't have the patience for it. So hopefully this all matches out. I didn't miss any data points. You can see why technology is kind of good. Sometimes trying to do some stuff by hand would be really hard to do, trying to gather all this data. And that's the power of a computer these days, is it allows us to absorb a lot of data. Oops. So it looks like our data lined up just fine. So again, what is this data all about anyway? Let's see here. I didn't even read it. The following data represents the width in yards and length in miles of various tornadoes. So we kind of are familiar with this from just a month ago of the tornado that hit us. That it was a monster tornado that had a huge wide path and went on for miles. But this is typical. If the width is 200 yards, they're saying it stays on the ground for about 2.5 miles. If it's 350 yards wide, it stood on the ground for 4.8 miles. So we have some data points here. Let's see if there's a relationship between the width of the tornado and how long it stays on the ground. So we hit the graph and see what we have here. Don't see a whole lot going on there. So all I see is the line. So let's clear this line off here. What's wrong is I didn't fix my window. Notice my window, the X values go from like 200 to, there's actually a 180 there. So on my window, I probably want to change my X min to maybe 0. And my X max, we may go up to, I see an 800. We may go ahead and go all the way up to 1,000. If I'm doing that, I may as well go by hundreds, so I don't have a whole lot of tick marks. The Y min 0 is probably fine. And the Y max, I don't see anything above 9. So we can probably just keep that at a 10 or something and just go by ones there. So if I now graph it, hopefully I have a little bit better luck error. And also that the data is kind of linear. It's kind of going in the same direction. So there is a little bit going on here. So there's the scatter plot trying. We've done that now. So draw a scatter plot of the data treating the width as the independent variable, which we did. What type of relation appears to exist between the width of the tornadoes? Well, for me, it looks kind of looks linear. So select 2 points and find the linear model that contains the 2 points. So select 2 points and find a linear model that contains the points. So we're going to call it linear. So let's see if we can find a linear equation that fits that. So I have, again, this equation is like y equals mx plus b. And we just got to select 2 points. I'm going to try to do like one that's really high, the 700 and the 9.0. So that would be one order pair, 700 and the 9. Let's pick a low one, the 180 and the 2. So just like they were doing before, they picked a low data point and a high data point. So I'm going to just choose those. The 800 would not have been bad either, 808. So we'll just do this and see what we get. So let's go ahead and just do what they did though. Let's pick the largest. What is the largest? 800? So 800 would be this 8. So let's just do that one instead. Let's not do the 180, not do the 700 one. That one looked good, but I think they were using the largest and the smallest. So we'll just do the same thing. And they look pretty easy to do as well. So I also have this 180 and 2. So if I change my y's, it's going to be 8 minus 2, and then 800 take away 180. So it doesn't matter who's 0.1 and 0.2, since I'm going to call this 0.2. I'm going to call this 0.1, because that makes my math a little bit easier to do in my head. So 8 minus 2 would be 6. 800 take away 100 would be 700, and take away 80 more would be 620. So what I have is a 6 over 620. Let's just go ahead and change that to a decimal. So if we go ahead and divide 6 divided by 620, that's going to give me this number here. So let's round that to like 4 decimal places like they were doing. 0.00. Where did it go? Come back. So 0.0096. Or actually probably 97 if I'm rounding correctly. So let's see what we got here. So now I have like y equals 0.0097x. And then I'm going to have plus b. And we're going to pick one of these points to substitute in for x and y. So I'm going to use that 8. So 8's going to go in for y. I'm going to have this 0.0097 times 800 plus b. So let's just go ahead and let the calculator do that for us. So 0.0097 times 800. That's going to give me 7.76. So I have this 8 equals 7.76 plus b. So then I got to subtract 7.76 from both sides. So 8 minus 7.76 equals then 0.24. So my equation is going to be y equals 0.0097x plus 0.24. Let's see what happens when we graph that, see if it does anything for us. So if I have y equals, and I have this 0.0097x plus 0.24, if we graph that, what's it do? It doesn't do bad. It does go through our data fairly decently. So I feel like I did my equation okay. That's not a bad line of best fit. So we are seeing a linear relation. This data is kind of staying pretty close to this data. I think the best line of best fit should probably go up a little bit more than that one. So let's see what else we have for us here. So we selected 2 points and we did this. So y equals 0.0097x plus 0.24. So I graphed the line on the scatter plot. That looked okay. Now we want to use the linear model to predict the length of the tornado that has a width of 450 yards. So using my model here, they didn't ask me to go do theirs, but if we did, let's see what they have. If I actually did that, the line of best fit. So if I hit the stat button, go to calculate, down to number 4, just move all the way through those pieces and hit calculate. And notice how they've got y equals, let me get this where I can see both here. So I'll put this down at the bottom. So y equals 0.0102 x plus 0.7372. That's what they have. And they have, notice how their R value is 0.908 or approximately 0.91 if around to 2 decimal places. So that, since it's pretty close to 1, this says this is a fairly good predictor. So the width of the tornado is kind of predicting how long it's going to stay on the ground. So if I hit the y equals button here, if we clear that off and use that one, 0.0102 x plus 0.7372. If I graph that, notice how that fits the data even better than what we did. So if we use this linear model, if we want to figure out the length of the tornado that has a width of 450 yards. So we want to find how long it stayed on the ground. So I'm just going to use this linear regression one. So y equals 0.0102 times 450 yards. And if I add that 0.7372, that should tell me how long it was on the ground, if I'm understanding how that was read. So 0.0102 times 450 plus 0.7372. If I hit enter, it says approximately 5.3 miles. So approximately 5.3 miles, since all this other data has been rounded to the 10th place, we're rounded to the 10th place. So, and that kind of mirrors up here, 400 was 4.5, 600 was 5.7, so that seems to fit the data pretty good, about 5.3 miles. So that would be E, 5.3 miles there. Interpret the slope found in part C. So the slope, basically, I'm going to just use the linear regression, the 0.01 over 1, if I do it that way. What I can do is move the decimal 2 places to the right and say, well, that's going to be 1 over 10. So basically what this is saying is, for every 1 mile, let me try that again. I didn't put my every there. So it's probably easier to see it more as whole numbers. So for every 1 mile of distance, I did that again. For every 1 mile of distance, the tornado is 1 yard wide. something to that effect. I'm sorry, 10 yards wide. If I use this notation, because remember the top was the length and the bottom was the width. So for every 1 mile distance, the tornado was 10 yards wide. That's kind of a description. It's easier to see a slope in the form of a fraction. And so a lot of times, like I said, you can kind of just move decimal 2 places to the right on the top to make a whole number, as long as you do that same thing to the bottom. And this looks a little bit easier to interpret. But basically the bottom line is the relationship is the top is the length and the bottom is the width of the tornado. So see if you find that useful as we move into our homework. Again, your homework may be a little bit more specific. So if you have any issues, just let me know and we can work we can look at those in class as well. But that should give you a good start into the assignment. All righty, have a good day.